Do you ever feel like you're just drowning in information, maybe even in your own company's data, but you're still searching for those, those golden nuggets of insight, the ones that can genuinely move the needle?
Yeah, I think we've all been there. You want to be truly well informed, make smarter decisions, but without spending like all day sifting through mountains of data and frankly really complicated tools. That's exactly why we do these deep dives. Today, we're taking a bit of a shortcut, a fast track really, to understanding something genuinely transformative. It's about how cutting edge AI, artificial intelligence, and machine learning are becoming incredibly accessible, even if you're not a specialized data scientist or some kind of deep learning guru. So our mission today is simple. We're going to unpack a comprehensive deep dive into this powerful tool called BigQuery ML. And look, this isn't just about getting lost in technical jargon or obscure algorithms. No, it's about peeling back the layers, seeing how it's a solution like BigQuery ML is, well, dramatically lowering the barrier to entry for something as complex as machine learning.
Get ready for some surprising facts, maybe a few aha moments along the way, and hopefully a clear picture of how these cutting edge AI capabilities are being put directly into the hands of, well, a much broader audience than ever before. It really feels like a fundamental shift in how businesses can leverage their data.
Absolutely. And what's truly fascinating here, I think, beyond just the technical specs, is that core promise of BigQuery ML. It's all about democratizing machine learning. For far too long, building sophisticated AI models felt like this really exclusive club, right? Accessible only to a select few with highly specialized skills, dedicated infrastructure, and frankly, a seemingly endless capacity for data wrangling. It was tough. It was often a huge bottleneck for organizations. They knew they needed AI, but they simply couldn't muster the resources or the expertise to even get started. So today, we'll explore how this tool aims to fundamentally change that landscape, making powerful predictive analytics available right where your data already lives inside your data warehouse. And importantly, we'll see how it's continually evolving to be even more robust, tackling new frontiers like unstructured data, which we'll definitely get into. This deep dive, I hope, will reveal how the headaches, the real complexities of traditional ML development are being systematically removed. It's opening doors for virtually anyone who works with data, especially, and this is key, those already proficient in SQL.
Okay, let's unpack that core idea then. This mission of BigQuery ML to make AI accessible to everyone. And like you said, it's not just a marketing slogan, is it? It's baked into its design right back from its launch in 2018. The concept was simple, but actually incredibly powerful. Enable users to build and run machine learning models directly where their data already resides in BigQuery, without needing to move that data that's huge, and crucially, without needing to learn complex new programming languages or tools like Python or R. Think of it maybe like this. For years, if you wanted to build some powerful custom machine, say a highly specialized engine for a really specific purpose, you needed a dedicated team, right? Specialized engineers, access to a bespoke workshop, the ability to fabricate custom parts from scratch, a massive undertaking. BigQuery ML is aiming to be the equivalent of a ready-to-assemble high-performance kit for that machine, accessible to anyone with a basic toolkit and, a foundational understanding of how to put the pieces together. It transforms that complex engineering feat into something much more like a manageable assembly process. And before BigQuery ML came along, the process of building and deploying machine learning models, well, data professionals often described it as a multi-step nightmare. I think that's fair. It wasn't just complex. It was often fragmented, prone to errors, and incredibly time-consuming. So let's really dig into what those pain points actually were, because understanding those historical challenges, I think, really eliminates just how elegant and impactful BigQuery ML solutions are.
Absolutely. Understanding the before makes the after so much clearer.
Exactly. So one of the biggest, most pervasive problems was what we often call the data movement nightmare. Imagine your organization, right? You've invested heavily, time and money, consolidating all your valuable information, sales figures, customer demographics, operational metrics into a central data warehouse, let's say BigQuery. You've spent immense time and resources on ETL, extract, transform, load. This is, the meticulous work. Getting data from various systems, cleaning it up, standardizing it, loading it into the central organized repository. That's a huge effort in itself, like building this meticulously organized, sprawling library where every single book is perfectly cataloged and
A
shelved.
huge investment, yeah.
Right. But then, here's the kicker. If you wanted to do machine learning on that data, you'd often have to take that data out again from your beautifully organized data warehouse. You'd have to copy it, transform it again for your specific ML environment, move it to a different system entirely. And this just created major issues. Data governance, for one. Who has access to what data? Where is it physically located now? Is it secure across all these copies? These are critical concerns, especially for security, privacy, regulatory compliance like GDPR or HIPAA. Beyond that, it forced organizations to create new, complex, often fragile data pipelines, specifically just for ML duplicating effort, increasing maintenance overhead. It was fundamentally inefficient, risky, and just prone to errors.
The library analogy holds up, right? Every time you want to read a book, you have to physically transport a copy across town, check it out, check it back in, return it. It's just an insane amount of operational overhead.
It really was. And that friction, that overhead, it slowed everything down. Sometimes it stopped projects entirely. Totally. And then there were the massive infrastructure and skills hurdles. Building and training ML models traditionally demanded highly specialized infrastructure. We're talking powerful, expensive computers, often with specialized GPUs, or entire cloud environments that needed painstaking provisioning, configuration, constant management. And critically, it required a very niche, highly skilled workforce. Data scientists proficient in complex languages like Python and R, people who deeply understood algorithms and statistical modeling.
Yeah, finding those people and keeping them was a challenge in itself.
Exactly. It created a significant bottleneck. It wasn't just hiring a few people, it was building out an entire specialized team, acquiring a completely new tech stack, figuring out integration. It was like needing your own supercomputer in the garage and knowing how to program it from scratch just to do some advanced calculations.
Mhm.
Most businesses just don't have that kind of specialized expertise or, frankly, the budget just lying around. This resource scarcity prevented so many from even beginning their AI journey. And okay, let's say you somehow navigated those first two massive hurdles. You moved the data, you built the models with your specialized team and infrastructure, then you faced significant deployment challenges. Once you finally built your model, tested it, proved it was accurate, the next major hurdle was figuring out where and how to deploy it. How do you get it delivering predictions at scale, reliably, efficiently in a real-world production environment? You might have built this beautiful high-performance race car, right?
Yeah.
Perfectly engineered, tuned for speed, but then you're left scratching your head, not knowing how to get it onto the track to actually race, how to fuel it, maintain it, monitor its performance. It's simply not enough to build an intelligent model. It needs to be put into continuous action to provide tangible business value. And that gap between development and deployment was often where many promising ML projects just stalled or completely failed.
Yeah, the last mile problem, as it's often called in ML, and it was a big one. But this is precisely where BigQuery ML really shines, because it directly addresses, and I say systematically solves, each of these traditional headaches. It transforms what was this multi-step, complex, often frustrating process into something far more streamlined, efficient, and crucially accessible. So the first major solution, which is truly a game changer, is eliminating that data movement. It's foundational. The key innovation, your data never have to leave BigQuery. It stays secure, centralized, governed within your existing data warehouse. Now for you, the business leader or data analyst listening, this means a massive reduction in operational complexity. Right away. No need for those complex, error-prone ETL pipelines just to get data ready for ML. But the deeper insight here, I think, is how it fundamentally transforms your data's security posture and auditability. Every time your data moves, it's a potential security risk, right? A compliance headache, an operational bottleneck.
So for businesses grappling with stringent regulations, GDPR, HIPAA, others, keeping data consistently within a single governed environment like BigQuery, without creating fragmented copies just for ML, that means a substantial reduction in your compliance burden, a significant leap in data integrity. Going back to that library analogy, it's like being able to read and analyze any book directly from within your well-organized library, without ever having to move it. You access it right where it is, you use it, and it stays perfectly in place. It reduces complexity, mitigates significant risks, and just accelerates your time to value for every ML project.
That makes perfect sense. Security and governance are huge.
Absolutely. Then, next, the entire burden of infrastructure management is completely gone, just vanished. When you're using BigQuery ML, you don't need to worry about provisioning servers, managing powerful GPUs, complex computing environments, none of that. You don't need to patch operating systems, monitor hardware, scale resources up and down. BigQuery ML cleverly leverages Google's massive, globally scalable computing power behind the scenes. It abstracts away all that infrastructure complexity, which means you can focus purely on the data and the models you're building to solve business problems. Rather than getting bogged down in the nuts and bolts of the underlying machinery, it's like having access to that supercomputer we talked about.
Right, the one in the garage.
Yeah, but someone else is handling all the power, cooling, network maintenance, everything. All you do is tell it what calculation you want, and it handles the rest. This significantly lowers the barrier to entry, both in terms of cost and the technical expertise needed. And then the true elegance, I think, the really transformative power of BigQuery ML lies in its simplicity for model training and prediction, all done with SQL. If you know SQL, and let's be honest, that's a foundational skill for almost anyone working with data in a business context today. You can now build and use sophisticated machine learning models. You train a model using a simple SQL query. Specifically, create a replace model. You point it directly to your data that's already sitting there in BigQuery. BigQuery ML then handles all the heavy lifting. It selects algorithms, manages computations, optimizes the model, scales to process whatever data volume you have, thousands of rows, billions of rows, doesn't matter. Once it's trained, you get predictions on new data just as easily using ML predict within another standard SQL query. And this could be for really practical tasks, right? Like forecasting future sales with remarkable accuracy, essential for planning, resource allocation, or maybe segmenting your customers into different groups based on behavior or demographics, invaluable for targeted marketing, personalization. All of this done directly within the familiar SQL environment. No switching tools, no learning new languages, no managing separate platforms. It genuinely empowers data analysts to become, well, citizen data scientists.
So this is really starting to paint a compelling picture. What does this all mean for you, the listener, the person trying to extract insights and drive value from data in your organization? The core value proposition of BigQuery ML, it sounds like, is incredibly powerful, precisely because it simplifies so much of what used to be, well, arcane and complex. You genuinely don't need those advanced data science skills. If you know SQL, you can do machine learning. That huge knowledge gap that used to stop so many business analysts and data pros from even touching AI, it's dramatically narrowed. There's no data movement, which keeps your info secure, avoids those common data governance problems, eliminates those redundant, complex pipelines, and you completely bypass all the infrastructure headaches. You leverage Google's massive computing power without managing servers yourself. This translates into real business benefits. Faster insights because the time from raw data to prediction is slashed. Fewer dependencies on highly specialized, often scarce, teams or external consultants. More control, more agility. And ultimately, it just provides a more streamlined, direct path from that raw data to actionable predictions that can genuinely impact your business or your understanding. Delivering competitive advantage where maybe before there was just a standstill. That's a really powerful foundation. That core promise of BigQuery ML is already transformative. But it sounds like BigQuery ML isn't standing still, right? It's continuously evolving. And from what I understand, there are some powerful new capabilities that make it even more robust, more versatile, really pushing the boundaries. Tell us more about these new frontiers. This sounds like taking it from ML for everyone to even more powerful ML for everyone.
You're absolutely right. While that initial premise was groundbreaking, the continuous evolution is where it gets incredibly exciting now. One of the most significant areas of advancement is its enhanced MLOps integration. Now, for you as a listener thinking about scaling machine learning within an enterprise, understanding MLOps machine learning operations is absolutely crucial. It's about automating, standardizing the entire life cycle of your ML models, from initial experimentation, development through deployment, and crucially, ongoing monitoring and governance. It's not just about building a model once, it's ensuring it stays performant, reliable, compliant, and production over time. And BigQuery ML is now deeply integrated with Vertex AI, which is Google Cloud's unified, comprehensive ML platform. This integration represents a massive leap forward in making robust MLOps a reality for BigQuery ML users.
Okay, Vertex AI integration, what does that actually mean in practice?
Well, for starters, any model you build directly in BigQuery ML can now be easily registered and monitored in the Vertex AI model registry. Think of this registry not just as a simple list, but as a central, intelligent library for all your machine learning models, regardless of where they were trained. In this registry, you can meticulously track their different versions over time, compare performance side by side using various metrics, manage them all from one consistent place. For an organization, this is invaluable. It ensures consistency across teams, vastly improves governance with clear audit trails, and makes managing potentially hundreds or thousands of models infinitely easier. It becomes your single source of truth for all your model assets.
Got it. A central library for models makes sense.
Exactly. Furthermore, from Vertex AI, you gain the capability to quickly deploy your BigQuery ML models for online, real-time predictions. This is absolutely critical for modern applications needing instant responses. Think real-time fraud detection, personalizing website recommendations on the fly, dynamically adjusting prices. Beyond just deployment, you can continuously monitor these deployed models over time. You can detect things like model drift or data drift. That's when the real-world data starts changing from what the model was trained on, which can degrade performance. And a key feature here, increasingly important for trust and compliance, is explainable AI insights. This means understanding why a model made a certain prediction, not just what it predicted. For instance, if a loan application is denied, explainable AI can tell you the specific factors that contributed most to that decision. That transparency is invaluable for building trust, debugging issues, and meeting regulatory requirements that demand insight into algorithmic decision-making. It's no longer a black box. You can peek inside, understand the decision process, leading to greater accountability, refinement, and confidence.
That explainability piece sounds crucial, especially as AI gets more complex.
It really is. And BigQuery ML now also boasts over 20 dedicated ML operations that can be seamlessly orchestrated within Vertex AI-managed pipelines. This is truly transformative for automating your entire workflow, creating robust, repeatable processes. Imagine setting up a pipeline that automatically retrains a model every time new data arrives, keeping it fresh. Or a pipeline that evaluates a newly trained model, compares it to the old one, and if it's better, automatically deploys it without manual intervention. This isn't just simple automation. It's about building robust, self-healing ML systems that continuously learn and adapt. It frees up your data scientists from tedious, repetitive tasks, letting them focus on higher-value activities. It ensures consistency, reproducibility, and accelerates the whole model lifecycle. That's the bedrock of enterprise AI.
And you mentioned Python support too, even though SQL is the main thing.
Yes, exactly. While SQL is undeniably BigQuery ML's superpower, opening it up to a vast audience, they've wisely added flexibility for those who prefer Python. You can now use BigQuery ML operations directly within Python to train and predict models. This is crucial for broader adoption and collaboration. It offers more choices. Python-savvy data scientists can integrate BigQuery ML into their existing workflows using familiar libraries. It means SQL analysts can collaborate more easily with Python data scientists, bridging that gap. It enables more diverse teams to work together, leveraging the strengths of both worlds.
Okay, the MLOps integration and Python support sound incredibly powerful for streamlining things. But this next one, for me, feels like a real game changer. It addresses this huge historical limitation that many data pros have faced. You see, historically, BigQuery was designed for structured data, right? Neat rows and columns like spreadsheets or database tables. It's great at that. But so much of the world's truly valuable data isn't structured. It's images, text documents like reviews or contracts, audio, video. This unstructured data has always been incredibly difficult to analyze at scale. So the incredibly exciting news is that BigQuery can now directly help you unlock insights from this unstructured data. This fundamentally expands the scope of what you can analyze right within your data warehouse.
Yes, this is truly transformative. It unlocks insights from this vast, often untapped reservoir of unstructured data. BigQuery ML now directly helps you extract value. For instance, you can use pre-trained models from Google, or even your own custom TensorFlow vision models to do things like object detection in images. Imagine being able to automatically see and categorize elements within huge photo libraries, maybe identifying product types in e-commerce images, or recognizing amenities in real estate photos.
Wow, directly in BigQuery.
Directly in BigQuery. You could even use it for quality control in manufacturing, identifying defects in product images, all using ML with the data warehouse. Current capabilities focus heavily on vision, but the roadmap clearly includes extending this to other types like text and audio. This opens up entirely new analytical possibilities that just weren't feasible before, gaining deep intelligence from visual assets and other complex data types.
That's fantastic. It really is all about flexibility, isn't it? And speaking of flexibility, there's another layer here that sounds incredibly practical. The ability to bring in models built outside BigQuery ML. So if you've got models developed on other platforms, maybe using different frameworks like PyTorch or even legacy systems, it's now easier to integrate them.
That's right. It makes integrating your existing investments much easier. This now includes popular frameworks like TensorFlow Lite, great for edge devices, and XGBoost models, known for their power with tabular data alongside standard TensorFlow.
And how does that work? Is it complicated?
Remarkably simple, actually. You just point to the external model using a straightforward SQL statement, and then you can run predictions right there within BigQuery, treating these external models almost like native BigQuery ML models. But what's even more fascinating, perhaps pushing the boundaries further, is this concept of remote model inference.
Remote model inference. Okay, what's that?
This is really useful in a few key scenarios. Say, if a model is just too large to import directly into BigQuery because of its size or complexity. Or maybe it's already deployed elsewhere and actively serving predictions, perhaps on a Vertex AI endpoint, handling real-time requests, or even within a serverless cloud function. BigQuery ML can now perform inference on those remote models.
So BigQuery talks to the model wherever it is.
Exactly.
Your data from BigQuery is seamlessly sent to that external model for prediction, and the results are seamlessly returned back into BigQuery, all managed elegantly within your SQL query, hiding the complexity of connecting to external services or managing APIs. This massively expands the range of models and deployment scenarios you can work with. You're no longer limited to just importable models. You can leverage almost any model, anywhere. And a really important application is model evaluation. You can use BigQuery to send data to multiple different remote models, easily compare their predictions side by side, or evaluate a production model against new incoming data. It's truly about extending BigQuery's analytical reach to whatever model you need, wherever it lives, maximizing your existing AI investments.
Okay, let's shift gears slightly. Forecasting. It's absolutely crucial for so many businesses, right? Predicting sales, estimating resource needs, anticipating market trends. Accurate forecasts are the bedrock of good planning. BigQuery ML's popular Arima Plus forecasting model, which is already pretty robust, now supports something called external regressors, or XREG. Expert, what does that mouthful actually mean for us? How does it make forecasting better?
It means your forecasts can become significantly more intelligent, more accurate, moving beyond just looking at past trends of the thing you're forecasting. Previously, Arima Plus, like many traditional time series models, relied mainly on the past patterns of the variable itself, just looking at historical sales to forecast future sales, for instance.
Right, just extrapolating the past.
It's exactly. Powerful for capturing seasonality and trends, but they didn't inherently account for outside influences. With external regressors, you can now include additional factors that you know influence your target variable beyond its own history. So when forecasting revenue, you can include highly relevant external data, like your marketing spend over time. Obviously, that impacts sales. You could incorporate upcoming holidays, which create predictable demand spikes, or even broader economic indicators, consumer confidence, interest rates, competitor activity if they're known to influence your business. This allows the model to capture a much richer set of influences, leading to forecasts that are far more robust and reliable because they incorporate a wider array of real-world variables. It moves from predicting based purely on what happened before to a much more sophisticated prediction. What happened before plus everything else we know influences it. And that translates directly into better inventory management, more precise staffing, more confident strategic decisions.
Feature engineering. It always sounds a bit technical, maybe a bit intimidating, like something only data scientists worry about. But at its heart, it's really just about preparing your raw data in the absolute best way so ML models can learn effectively from it, right? Transforming raw data into features that highlight patterns. And BigQuery ML is adding a whole host of new numerical and categorical feature engineering functions to make this easier, more powerful, and importantly, more accessible to SQL users.
That's precisely right, and it's incredibly important. The quality of your features directly impacts the quality of your model's predictions. Garbage in, garbage out, as they say. Poor features lead to poor models, no matter how sophisticated your algorithm is. So these new functions streamline that often tedious, manual, complex process of transforming raw data into useful features. Things like binning numerical data, handling missing values gracefully, encoding categorical variables numerically, all within SQL. But there's another critical enhancement here, one that addresses a very common, very frustrating pain point in deploying models. When you export BigQuery ML models now, the transform clauses, essentially the exact rules and steps used to prepare your data during training, will also be exported with the model.
Okay. Why is that so important?
Because it simplifies online deployment immensely. It means the deployed model automatically knows how to prepare any new incoming data in exactly the same way it was trained. This ensures perfect consistency and accuracy in real-time predictions without extra manual effort or separate coding. It solves that nagging problem, ensuring the data you feed your deployed model in production looks exactly like the data it was trained on. That's vital for reliable performance over time. It takes a huge amount of headache out of the operational side of ML.
Okay, all these new features sound incredibly powerful in theory. They promise great things, but how do they actually play out in the real world? How do these capabilities translate into tangible business value? This brings us to a fantastic customer example, a real-world case study showcased by Candace from Google. It involves Twitty, a leading vacation rental company, and their partner, AdSwerve. Now, Twitty, like many businesses today, faced common challenges. challenges that many of our listeners, especially those with a big visual component to their business, probably recognize. They relied heavily on traditional structured search data. Their photo selection for property listings was very manual, very time consuming, and they found it incredibly difficult, almost impossible really, to analyze their vast library of images using traditional ML tools. They knew their images were critical for attracting renters, but they couldn't actually analyze them at scale or truly understand their impact. It sounds like a familiar story sitting on a gold mine of unanalyzed visual assets.
Exactly. Twitty had thousands upon thousands of beautiful house images, crucial for their business. But they were just stored as raw files in Google Cloud Storage. Great for storage, sure, but not set up for direct analytical processing. The breakthrough came with a brand new BigQuery ML capability. They could now create an object table that points directly to these images. This made their unstructured image data accessible right inside BigQuery using simple SQL, as if the images themselves were just rows in a table.
Just like structured data.
Effectively, yes, from an accessibility standpoint. Think of it.
Oh.
All their photos in a giant digital album, suddenly visible and understandable directly by BigQuery. No need to manually move them, pre-process them in some separate system, or write complex custom code just to access the visual content. This alone is a massive simplification. It bridges that gap between raw visual assets and actionable analytics, truly democratizing image analysis for organizations without, say, a dedicated computer vision team. Previously, this would have been a whole separate, complex pipeline, now consolidated within BigQuery.
Okay, here's where it gets really interesting. A bit magical, maybe. Once those images were accessible in BigQuery via that object table, Twitty then used another powerful BigQuery ML capability. They imported a pre-trained vision model, specifically TensorFlow's ImageNet model, directly into BigQuery ML. Now, this model, this incredibly intelligent neural network trained on millions of images, doesn't just identify objects. It translates each image into a series of numbers. These are called image embeddings. Can you explain what these embeddings really are? Why are they so crucial?
Absolutely. These image embeddings are essentially a high-dimensional numerical fingerprint. They capture the semantic and visual characteristics of the image. Think of it like this. You upload a picture of a house. Maybe it has a pristine pool, lush landscaping, stunning beach view at sunset. The model doesn't just label it house or pool, it translates that rich visual information into a long sequence of numbers. Each number in that sequence represents a subtle, learned aspect of the image. Maybe one number signifies water features, another daytime lighting, a third modern architecture style, and so on.
So it's like the AI describes the image using a unique numerical code.
Exactly. It's breaking down complex visual content into a highly detailed, machine-readable language. These aren't just random numbers. They represent the rich visual info in a format the machine understands. Twitty even used principal component analysis, PCA, a statistical technique, to reduce these high-dimensional embeddings down to a more manageable 39 key features. That's a crucial step, makes the data more manageable for analysis without losing too much information. Boosts efficiency. Ultimately, these numerical representations are what allow an ML model to understand and effectively use the visual information from images, treating them as just another set of powerful features. It allows the AI to compare and categorize images based on their actual visual essence, not just keywords or manual tags. Incredibly powerful for finding specific amenities, determining image quality, finding visually similar properties, all without manual tagging.
Wow. Okay, so they have these numerical fingerprints for their images.
Right, and this is where the magic truly happened, where the power of BigQuery ML to combine these seemingly disparate data types really shone and delivered concrete business value. Twitty then combined these new image embeddings derived from their unstructured image data with their existing structured search data. That structured data included vital property attributes, number of bedrooms, proximity to the beach, square footage, Wi-Fi, other amenities, the usual stuff. All of this, the visual fingerprints and the traditional property details brought together into a single unified table within BigQuery. They then build a sophisticated wide and deep model directly in BigQuery ML.
A wide and deep model. What's special about that?
It's a powerful type of neural network. It's particularly good at combining two learning approaches. A wide component learns simple, direct correlations like beachfront properties are popular, and a deep component uncovers more complex, nonlinear relationships between many features, like the subtle interplay between certain image embeddings and property size, or how a pool in a certain architectural style might predict higher engagement. This hybrid approach captures both obvious and nuanced patterns in user behavior, leading to highly accurate predictions. And the ultimate goal, to predict the click-through rate, or CTR.
The probability of a user clicking on a particular rental listing based on all this combined structured and unstructured information. This sophisticated combination in one place for a single prediction task. It's a prime demonstration of BigQuery ML's capabilities, delivering comprehensive insights that just weren't possible before.
That's an incredibly powerful combination. But this raises a really important question. Once they had this model predicting CTR so accurately, how did they know why it was making those predictions? What specific features out of all that structured data and those complex image embeddings were actually influencing the clicks? Knowing the why is crucial, right, for taking effective action rather than just trusting a black box. And that's where BigQuery ML's ML Global Explain function came in. It provides that transparency.
Exactly. Twitty wisely used ML Global Explain to understand the driving factors, to peel back the layers of that black box and see what was truly contributing to the predicted CTR. And the results, they weren't just fascinating, they were quite surprising and fundamentally shifted Twitty's understanding. They discovered that image-related features, those numerical embeddings, and the derived image labels like swimming pool, beach, daytime, extracted from the photos, accounted for a significant 57% of the explanation for the CTR.
Wow, 57% just from the images.
Exactly. Much higher than they had expected. It suggested visual elements were far, far more influential on user engagement than their traditional structured data alone indicated, or even what their intuition told them. Specifically, they saw images featuring water pools, beaches, and daytime views consistently led to significantly higher clicks. While elements like porches or stairways were found to be less impactful, this was a profound aha moment for Twitty's marketing and content teams. Concrete, data-backed evidence for what might have only been hunches before, or even contradicted their assumptions. It gave them a clear, data-driven mandate for optimizing their visual content strategy.
The insights Twitty gained from this deep dive using BigQuery ML were immediately actionable, which, as we always say, is the ultimate goal, isn't it? They can now run far more informed A/B tests to optimize their listings, knowing exactly which visual and textual elements are likely to perform best based on real user behavior. That leads to truly data-driven decisions, improving CTR, which means more bookings, more revenue. Simple as that.
Exactly right. Their content and marketing teams can now use these precise data-backed insights, choose and edit photos more effectively for new listings, optimize existing ones. For example, if a nighttime photo wasn't performing well, they now have data-backed proof that swapping it for a bright, appealing daytime photo of the same house could lead to significantly better user engagement and higher CTRs. Takes the guesswork out of content creation. And the best part, all of this sophisticated analysis processing vast quantities of unstructured images, building and explaining complex predictive models, combining disparate data sources, all done using SQL. It aligned perfectly with the existing skills of their business analysts and data teams. No need to learn entirely new languages or manage complex infrastructure. It truly demonstrates how BigQuery ML empowers organizations. Combine diverse data, build sophisticated models, gain incredibly actionable insights, all within a familiar, scalable, efficient environment, truly democratizing the power of AI. #outdrought.
So what does this all mean for you, our listener, as you navigate the world of data and business intelligence? Our deep dive into BigQuery ML today really highlights how advanced AI and machine learning are becoming, well, exponentially more accessible than ever before. It's no longer just the exclusive domain of specialized data scientists needing complex infrastructure. With intuitive, powerful tools like BigQuery ML, truly profound insights are now within reach for anyone familiar with SQL. It's about seamlessly bridging that gap between raw data, whether it's neat rows and columns, or vast amounts of often overlooked unstructured info like images, text, audio, and meaningful actionable knowledge that can directly impact your bottom line.
And if we connect this to the bigger picture, it profoundly underscores the immense value of looking beyond traditional data silos. The Twitty example beautifully illustrates how combining seemingly disparate data points like structured text descriptions and rich visual information from images can unlock entirely new levels of understanding about customer behavior and drive significant, measurable business impact. Moreover, that ability not just to build models, but to understand why they make predictions through features like explainable AI, that's absolutely crucial. Transparency is vital for building trust in AI systems, for knowing how to iterate and improve them effectively, and for truly leveraging AI for critical high-stakes decisions. This is the tangible future of data-driven decision-making, where the technology adapts to existing skills within an organization rather than demanding entirely new, scarce, expensive ones. It's a paradigm shift towards greater empowerment.
So, as you go about your day, maybe thinking about your own organization's data assets, How might you rethink the vast amounts of information you have access to? Especially there's often overlooked unstructured bits images sitting in file storage, customer feedback in text documents, audio recordings, social media posts. How could leveraging powerful, accessible AI tools like BigQuery ML unlock new value and surprising, perhaps counterintuitive insights in your world? Just like it did for Twitty. That's a truly powerful thought to mull over, isn't it? And an incredibly exciting area to explore further as you seek to gain a genuine competitive edge in today's data-rich environment.